A very common question when you work with line is, does a certain point lie on a line? Right? So you're given a point P, you're given a line. The question is, does the point P lie on the line? Now, how do we answer that? Let's look at this example here. In this example, we are given the line G here that goes through 2 points, and we are given the point P1 and P2. Question is, do P1 and P2 lie on G? Okay, how do we approach that? So the first thing we do is we get the point direction form of the line G, this one here. Now, we have discussed this in the past. If you don't remember how to get this, have a look at previous videos. So basically, you need a position vector. We choose the vector 4, 0, 4 here. And then you need a direction vector. So that's the vector from this point to this point. So -4, 4, and -4, right? So this point direction form describes our line G. Now the question is, does P1 lie on the line, right? Now, to answer that question, let's quickly repeat what this point direction form really means. So this point direction form gives us points on the line by varying the variable t, right? For different values of t, we get different points. So if this point here, P1, lies on the line, then this means actually that there exists some t that we get this point, right? So the big question is actually, does this t exist? That this equation here holds true. Yeah, we are looking for a t that this equation holds true. Now, there are two ways how you can approach this. First method is, well, you actually get 3 equations by looking at this up here. So the first equation is in the first component, the x component, you have 8 needs to be equal to 4 minus 4t. Second component, so the y component, needs to be -4 plus 0 plus 4t, and the last one is then 8 equal to 4 minus 4t. So 3 equations, 1 unknown, and those 3 equations would need to be true simultaneously if the point lies on the line. So we can solve for one equation. Let's, for instance, solve for the first one. You solve for t, so you take this to the other side, then solve for t, and you get t is equal to -1. Okay, t equal -1. This means that the other equations should also give us t -1. So we could solve now also the other equations, check whether it's whether we get t -1 also here and also here. Or alternatively, we can plug this in here, and then check whether we get that value. So let's do this. If we plug in -1, here we get 0 plus -4. So it's -4. Okay, this one is correct. And the last one, plugging in -1 here, so it's 4 minus -4, so +4, and +4, and this will be 8. So this one is correct as well. So this tells us, yes, P is on the line, right? That's the first way how you can solve that. Second way is, it's kind of similar, right? We still start with this one, but what we do, we don't write down these equations, but we actually use vector algebra. So we can actually subtract this vector here from both sides. So we are left with 8 minus 4, 8 minus 4, 0, 4 should be equal to t times the vector -4, 4, 4. Now this part here, this gives you 4 minus 4 and 4. Okay, and then we already see directly that this holds true if t is equal to -1. Okay, good. In that case, let's look at the second point P. So we have the point P2 here, and the question is, does it lie on the line? Point P2 has the coordinates 3, 1, 2. So again, if it's on the line, then there needs to be, then there needs to exist some t so that this equation here holds true. With the first method, again we get three equations. So the first one reads 3 is equal to 4 minus 4t, and then you also see the second and the third equation. Again, they need to be fulfilled all three simultaneously. So let's solve the first one again for t. If we solve this for t, then we have, well, let's take 4 to the other side. So we have -1 is equal to -4t, and then we divide by -4. We divide by -4 both sides, so we will have t is equal to 1/4, 1/4. Okay, this gives us t equal to 1/4. Now again, we could solve the other ones, check whether t is also equal to 1/4. If it's 1/4, then p is on the line. If we get different values for t, then we know that it's not on the line. But we can also plug this in. So let's plug it in. Again, we plug this value in here, and we check if then the first equation should give 1, the second one should give 2. So here we have 4 times 1/4. That's indeed 1. So this one is correct. Okay. We are still confident that it could be on the line. Now let's check the second one. Here we have 4 minus 4 times 1/4, and this is equal to 4 minus 1, so this will be 3. And now we get a contradiction. 2 equals 3. Well, that's definitely not true. So this doesn't, this equation doesn't hold here. And so we know that P2 is not on the line. Right? Same result we should get with the method, with the second method. Second method, again, we subtract this part from this part. So we'll get -1, 1, -2. So the question is now, is this equal to t times -4, 4, -4? And looking at the first line here, so we should have -1 equal to t minus 4, so t in this case becomes ¼ right? Now checking that, if we use t equals to 1/4, then 1/4 times -4, 4, -4, oops, would be -1. This would be 1, and here we have -1. Again, that's a contradiction. The first two components are correct, right? We have -1, -1, 1, 1, but the last one here we should get a -2. So again, we got this contradiction, and we know that P2 doesn't lie on the line because we have this contradiction. So to summarize that, if you want to check whether certain points lie on a line, then well, you need to have your point direction form of a line, and you need to check whether you can find some t to get to that point. And if you don't find that t, then the point won't lie on the line.